So we've got an electric motor consisting of a coil of wire between the poles of a magnet. The motor is connected to a lamp. A thread wrapped around the motor spindle is used to support the weight, as shown in figure 2a on the topic. So we've explained why the lamp lights when the weight descends. So we're on to part B, which is what difference would have been made if the magnet had been much stronger. So let's work through this. Increasing, so what we're going to be doing is increasing the magnetic field strength, which is normally known as B. So increasing the magnetic field strength, and that would result in the light being brighter and the weight falling slower. So the light would be on for longer. Now, this is a little bit hard to explain, but let's work through and make sure you understand. So what's happening to drive this motor around is you've got a weight that's going to fall from the top position all the way down to this at the bottom. So that weight, as it falls through that height, is going to lose gravitational potential, mgh. Now, if there's no magnetic field in the motor, so there's no motor there, all that's going to happen is that weight is going to fall down, and ignoring air resistance, etc., your kinetic energy you've got when you get to the bottom is going to be equal to the gravitational potential energy. So you'll be falling at 9.8 meters per second squared, basically as g. And the only force that's on you as you fall, is on the weight as it falls, is going to be its weight. Now, let's introduce the magnetic field in the motor. So in this scenario, what's going to be happening is the weight is still going to fall. So the kinetic energy the weight's got when it gets to the bottom is going to be less than the gravitational potential that it's lost as it's fallen down. Written another way, what we could say is the kinetic energy is plus the electrical energy that we've got out is going to be equal to the gravitational potential energy we have lost. And I'm assuming there's no losses through the system. So that means that basically the electrical energy that we get out to power the light bulb would be the gravitational potential energy lost minus the kinetic energy we've got because we're moving when we get to the bottom. So what I've done is I've put a stronger magnet in there, which means that for a given speed that the motor is rotating, I'm getting a bigger in EMF and a bigger current, and hence more energy out. So the way that actually happens is my weight now not only has weight acting down on it, pulling it down, but there's now a tension actually in the piece of string because of the resistance to the motion, because of Lenz's law, because you're inducing an EMF. So the net summary of this is you're taking more energy out because you've got a stronger magnetic field in the motor. Now, if I'm taking more energy out, it's got to fall slower because it ends up with less kinetic energy at the end, and it's falling slower because it's got a smaller acceleration. Because this motion is now opposed by the motor, which is introducing a tension because of Lenz's law, because it's resisting the motion that's caused the induced EMF. So the motion that's causing the induced EMF is the weight going down. Therefore, Lenz's law means there's going to be a resistance to that, which is a tension in the piece of string pulling it back up again. Thank you very much.